Alright, another DraftScience video presentation. Okay. Comments, basically the same subject, energy, sort of an important one. And, through this bullshit, there is some value in it in the sense that you have to keep going, trying to find simpler and simpler analogies, simpler ways to explain, to clarify that there can't be reasonable disagreement on some points made here. And, unfortunately, though, people keep forcing you to go another step further, even though you've already made it so clear. So I'll attempt to make it even clearer, illustrate the point more directly. And it's, like I said, there's some value in it in the sense that, yes, you're obliged to look deeper and deeper into the mechanics and be more and more explicit and more careful. And there's some value in that. But anyway, so Jerry Hall, who concedes absolutely nothing, never admits he's wrong. He has all of these flaws he claims he sees in other people, and it's just so bullshit. So he has made hundreds of videos where he is wrong. Well, it's just a lie, so you can say it, but it's just wrong. I certainly said things, I believe things for a number of years, and so you could argue I said the same thing over and over and it was wrong. And all of my mistakes have been superfluous to the theme. The theme is that physics can be broken down into very simple mechanical mechanisms, and that all of these extraordinary claims made by conventional physics are way under evidenced, way under proven, and there are mechanical explanations that are just as good at explaining the phenomenon. For example, the radar type 2 slit experiments, where the simple explanation of jamming the frequency works fine. No need for superpositions and entanglements or any of that nonsense. It's a fact. It's been over and over illustrated, and they'll concede nothing. And they'll just keep claiming somewhere it was proven that it doesn't work, when no, it was never, ever, ever counter-argued in any coherent manner whatsoever. There's zero evidence, just like there's zero evidence that anybody ever made a photon detector. All of this crap is just that crap. All right, and again, these assholes will concede nothing. I made 3 videos on 3 subjects, pretty specific: gravity, the 2-slit experiment, or light in general, photons. What is a photon? And then energy. And nothing has been stated to counter anything in those videos at all. Nothing. All right, even offered money to prove that he is wrong. Yeah, so that should be something to my advantage, to my side, in the sense that that's a lot of money too. $2,000 to prove me wrong. Not insubstantial incentive for if I'm just so obviously a bad person and have lousy arguments. Why are they all afraid of me? Why doesn't, Ken Wheeler loves money. Come on, $2,000? Let's get real. Why isn't he taking the money? Oh, that's right, because he's not going to be able to make me into an asshole or a buffoon or do any of that stuff. He's the one that's going to be on the defensive. Alright, there is no way he will ever make a video and say, excuse me, I was wrong. So I just did that 2 weeks ago. I overtly made a stupid video, where I insulted everybody in a forum and said all this shit because, yes, I just, for whatever dumbass reason, forgot my grammar school education and thought you went twice as high in gravity to get twice the velocity, and it's 4 times. Yes, I made that mistake. I admitted I made that mistake. I basically indexed the video, didn't delete it, but I basically discouraged viewing it because I was wrong. Oh, shit. So, it's just such a bullshit. Even if he realizes it. So again, this is, what's the counter argument to you? You're a fucking liar. Okay, so show where I'm doing that to conventional physics, where I'm lying about them. Show me my lies about your behavior. Show me my lies regarding Richie or Stephen Bro or any of these assholes, Ehothliday, whatever. Show me where I'm lying about them or to them, you fucking piece of shit. Oh, you're such an unaccountable piece of crap. Man up and make your counter physics videos. That are going to be telling the truth. Momentum is conserved in a closed system. Energy is conserved in a closed system, supposedly, right? I mean, I've already made a pretty good proof demonstrating that, well, if you consider gravity, it might be a case where, yeah, energy isn't actually conserved. You're actually using it up. That's what's making the gravity. You really can't have gravity unless somehow you get rid of some energy and cause the convergence. But anyway, regardless of that example, I would generally speaking state that yes, in most systems that are more complicated than gravity, gravity is the most elemental force, you could argue, the energy has to go somewhere. It doesn't disappear. And what you're not understanding is you can't conserve it. That is, you can't transfer 100% of the energy from item A to object B and then argue, but there was a bunch of energy losses. That's retarded. It's so fundamentally retarded and stupid. And you won't even concede this. So it's, again, I have to draw it, and you're saying, well, why should I have to keep arguing this? This is, 10-year-olds can get this. This is not complicated. And I've put it in, I've given examples that are so elemental and so simple, and yet you're still arguing this as if you have any credibility at all. Like you could point to a single example in all of recorded scientific investigation to defend your bullshit. Oh, so obnoxious. So again, the simple argument made in the Physics Girl video, which is just outrageous, and the fact that nobody, none of these physicists will come to the defense of the truth. AB Science or any of these real physicists who know that's just nonsense. All right, so we have one object's going twice as fast as the other, and their masses are inverses. So this has a 5 mass, this has a 10 mass, this one has a 5 velocity, this one has a 10 velocity. Now, by momentum, okay, mv equaling energy, right? These two objects have exactly the same. They have 50 units of energy, okay? 50 units, whatever we want to call the units, okay? They are actually in kilograms and meters per second is the velocity, so it has the units to be called a joule, whether it's a joule times 10, it doesn't matter. But their kinetic energy formula that I'm saying is just an absolute nonsense, invented for no good reason, exists by religious, it was called the living force, all kinds of reasons to be doubtful of the integrity of this nonsense. Started off as just mv squared, so for 50 or 60 years it was mv squared was the formula, and then they put the 1/2 on it after 50 or 60 years. So it was already 100% off. For 60 years, it was that bad at getting the right answer. All right, so anyway, so just to, and I pointed out that the v squared is just the fact of the inverse square law when it comes to how gravity actually works, the sense that you have to, velocity means that the same energy, okay, can take you twice as high if it's in the form of velocity. That has a bias for velocity because it's a moving force. It's a continuous force. It's coming at you. So, I guess I can do that analogy here because I'll use it later. The idea is to understand that force comes in two forms, right? If I could just say that force is in units, like little sticks, and that, in a situation you can have two different circumstances. You can have a conveyor belt where the sticks are moving towards you, and you can have one where the sticks are just static. They're in the road. Okay, like friction or something. And the trick is even when they're static, The trick is that at certain velocities you can just break the friction. You can disregard it, but you break the board. Okay, so it's little boards on springs, and you're going to knock the board on a spring. So every unit of friction is there, and it's going to bend. And as it's bending, you're going to lose energy. You're going to have to bend it. You're going to have to push on it. And that pushing force will go into the ground, okay, and it'll take away your energy. And it'll take it away whether it's in the form of momentum or whether it's in the form of kinetic energy. You can't avoid the fact that friction or force takes away your momentum or your energy. And it doesn't matter what form it's in, kinetic energy or momentum. It has to take it away. If you don't hit anything, you keep going in space. If you hit something, you slow down in space. You never hit something in space and go the same speed. I mean, it's a ludicrous proposition. All right, so so there's another trick to it, right? You can break the board. So if you're going 50 miles an hour, you can just snap all the boards and you won't get the full measure of their friction. You won't feel the full measure of their pressure because you snap the board. All right. But generally speaking, if you're not snapping them, you can understand that if the force is coming at you, the conveyor belt's moving, and it's moving more boards at you, okay, every moment of time, that's a different circumstance than this one where time is irrelevant. Time doesn't mean anything in this circumstance. The boards are just stuck in the ground, and the fact is, if you take 10 years to smash them, or you take 10 minutes to smash them, or you take 10 seconds to smash them, all you're doing is smashing a number of boards that will take away a little bit of your velocity. And that's all there is. There's no time equation involved. It just doesn't matter how fast or slow you decide to go through the boards. You're going to have to absorb the energy they're going to push back at you with. Where in the circumstance where it's on a conveyor belt, you can understand that how fast I go through is going to change how many boards I have to bend. I bend less the faster I go. Just a fact. So if I get the job done quickly, I'll use less energy. That is, I'll have to sacrifice less energy because I'll hit less boards. Now that's the reality. So gravity and magnetism, they're in this category. They're time dependent. The longer you're in them, the more force they're going to impose on you. The more boards they're going to hit you with to slow you down. Where things like friction or banging into another kinetic object, no, it doesn't really matter how much time you take. It doesn't matter how fast you go. There will be no bias for your velocity. You will not go further because you're going faster. All right. So that's, there should be nothing like anything called an argument about these facts. Okay, it really shouldn't be. All right, so the simple argument is that if I transfer the energy between these objects, and I could transfer it a million different ways, or I can just smash them into each other. I could put magnets on them, make it more efficient, little north-side magnets, because we know magnets basically give you back what you put in. And I can make it a very efficient transfer. I can have very good wheels, I can have lots of things, and I can make it so you're not going to lose any momentum by transferring. Now, I also could just put generators on the wheels. All right, and I could take all the energy off of this and turn it into electricity, with a generator, and then I could just put the electricity into a motor on the wheels on this one and make this one go. Now we know we're going to have losses in the electrical lines and all that kind of stuff, but the fact is you could probably do it where you wouldn't notice the difference. This would be, instead of getting, your 5 in terms of velocity, you're 5 miles an hour, you'll get 4.8276, right? So it'd be pretty close. But the truth is, any losses have to come out of this. So no matter what system I make, if it's absolutely, perfectly efficient, that is, it's perfect, then this is what I'll get. I can take this object and I can bang it into this object, the light object, and I can bang the slow object into the the fast object into the slow object, the heavier one. The lighter one I can bang into the heavier one, and I can transfer all of the energy. And I explained why you can't do the inverse. Because as you're doing the inverse, that is, as you're taking something slow and banging it into something light, something heavy and banging it into something light, what's going to happen is, as soon as the light thing reaches the 5 miles an hour, it's going to leave contact. So as soon as it's going 5.1, miles an hour, as soon as this one goes 5.1 miles an hour, it's going to lose contact with this object, and this object isn't going to be able to transfer more energy. And so this one will go some measure above the velocity of this object, and this object will end up going some measure below what it was previously going, whichever, 2.38. And so the transfer isn't as clean going backwards because of just the fact that, if if I bang into something with something heavy, and it starts going as fast as I'm going, I can't transfer any more energy. All right, where the other scenario works just fine in the sense that if I hit it with more velocity, then I'll definitely be in contact all the time I need to go to the 5 miles an hour. 5 miles an hour is always going to be less than this, so I'm going to have a much easier time transferring the energy. So the fact is, though, is in the thought experiment being used for all of this conversation, the rule is that I made a 100% transfer. 100% of the momentum made it from this object to this object. And it's revealed in the statement of the velocities and the masses. No mass lost, no velocity lost technically in terms of the momentum. And there's no way then later you can say, well, because of this idiotic, stupid, moronic formula, I'm going to argue that this object has 500 joules of energy and this object only has 250. And I'm going to make some idiotic statement that somehow I lost half the energy. Is gone. Now, even if I never bang them into each other, do you really think this object has twice as much energy as this object? I mean, it's ludicrous to think so. It's ludicrous to think that if I did put a generator on the wheel, okay, and that causes friction, causes the creation. It's like a turbine put in the water. It takes energy out of the water. Well, the turbine will consume the energy. Do you really think I'm going to get 500 watts from this object and I'm only going to get 250 watts from this object? Do you really think that's what's going to happen? I mean, I made analogies. Do you think the little stream going 20 miles an hour, has more energy than the big stream going 10 miles an hour? I mean, do you really think that's how the world works? Well, then you're thinking so wrong and pathetically wrong. This is obviously nonsense. It doesn't work. It doesn't make any sense. You cannot conserve the momentum and lose energy. It's impossible. I just don't. How do I make it any simpler? I mean, it's so simple already. The argument is so obvious and in your face, and you just keep doing this denial like you have some ground to stand on, like you have an argument somewhere. You link to absolutely nothing to demonstrate where this experiment was done, and you collected the energy, and you got twice as much energy from the fast thing. And the only thing you keep doing is pointing to some gravity experiment where we've already conceded that gravity is a moving force. So the faster you go into it, the less of it you're going to encounter. So it's really a poor way to measure measuring how much distance you travel in gravity is a very poor way to measure your total energy. All right, momentum is conserved in a closed system. Let's understand all systems are closed to some degree or another. All right, the whole universe is closed. You could argue that I could go to the surface of the earth, and closed doesn't mean anything. Closed means that the energy stays close to you. Okay, it can't get too far. All right, it ends up hitting stuff and bending and curving and coming back to where you are. It's stuck in a system. All right, the system says you really can't go anywhere. You could almost say the thermal energy inside the Earth is sort of like that, in the sense that even the sun, they make the argument that the photons that finally get out of the sun took 1 billion years to get to the surface of the sun, because the sun is pretty much a closed system in that sense, until you get to the surface. How else to explain it? There's no place for the energy to go. We already know what all the sources are. You can make heat, you can make sound, You can move objects, you can break pieces off. There's lots of different ways or forms the energy can come off, but you cannot transfer 100% of the momentum and then argue there were some effects, environmental effects that were significant. That somehow 100% of the 50% of the energy was lost to some environmental effect. It's absolute nonsense. All right. It should be obvious. This is the part that's just, you're so incredibly wrong and then talking about what's obvious. It should be obvious that energy is lost in a collision. No, it's obvious that you can minimize the losses. You can put little carts on air tracks, okay, and really reduce the friction. That is, the object could actually, you can keep something bouncing between two springs on an air track for an hour. Give them a tiny bit of energy and they'll just keep going for an hour. It'll take a long, long time. So the more you can get rid of these friction effects, the leaking to the environment, the more closed you can, the more of a trap you can make for the energy. The fact is they can do it a long time. It's like light bulbs burning in a vacuum. You want the filament to last longer? Yeah, well, make it impossible for the pieces of the filament to go anywhere. So create a vacuum and they end up sticking back on the filament. It lasts longer that way. Oh, you're just so stupid. Anyway, it should be obvious that energy is lost in a collision. So the argument is it would be a tiny, you could argue that, again, I would argue that yes, you can't really bang two train cars into each other and expect that all the energy will be transferred. But the fact is that 99.9% of it can be transferred. And in the thought experiment that starts this subject, it is stated, overtly stated, 100% of the momentum was transferred. So there were no losses. That was an overt statement, a premise. So here you are, it should be obvious that when the overt premise, the statement made as a fact of the experiment, is stated to be a fact, that you can't say there's losses and the fact. Those two things can't happen. So when I make a statement and say there were no losses, and that's what was done in the video. That was the argument. So you're just such a weasel. Anyway, if things collide and energy is lost, but momentum remains the same, okay, then momentum can't be energy. So there we already know that, okay, so you just don't believe in Newton because you'll break every bit of Newton's mechanics. If Newton has to concede there's losses of whatever this is called, this idea that you can have something meaningful called momentum, but it doesn't mean anything. It's not really its energy. When everything about what Newton's saying is it's fundamental to its energy. It's fundamental to what it's going to do. At every moment you're measuring its momentum. You're saying what's its vector of momentum? Where is it heading? Where is the mass going? And at what speed is it going there? I mean, it's so elemental. All right, so I'll just read that again because it just makes no sense. If things collide and energy is lost, but the momentum remains the same, then momentum can't be energy. So he's just being preposterously defiant in defending the nonsense formula. The formula that came after and that has really no credibility. It was never scrutinized by, like, again, it wasn't the Royal Institution. This wasn't something the Royal Institution got to hear and argue. This was argued in the press. This was argued distant from, okay, in other countries because, they were anti-Newton. They couldn't go to England with this nonsense because they knew there'd be a bunch of people who would argue in defense of Newton. All right, so, it's a terrible formula. It's a terrible nonsense. And you're saying that somehow it's more credible than the momentum argument when everything that Newton talked about made sense because of momentum and conservation of energy. I mean, you don't even realize how preposterous the world would be if you actually lived by this silly formula and didn't use this momentum formula. Anyway. Momentum can't be energy. It's just a result of Newton's law. Now, it isn't. It's not anywhere near a fact. Okay, that is a contrivance invented years later. All right, it has nothing to do with Newton. It's not a derivative of momentum. This squared thing is not a derivative of mv. It's a nonsense to say it is. You didn't derive anything. You just added crap. And it's crap. All right. Okay, it's just a result of Newton's law that for every force there is an equal force in the opposite direction. Well, that's just absolute nonsense, because it's pointing out how, depending on what you hit, you make energy or you destroy energy. Again, I just reverse the circumstance and say I crashed the heavy thing into the light thing, all right, and I can argue that I just made energy. I made extra energy. I doubled the amount of energy. And I think, again, logically, if I asked you what train do you want to hit your grandmother, if we go with this idiotic formula, okay, the truth is you're going to pick the wrong one. I can create a circumstance where they in fact do have different energies, and you're going to say they have the same energy because of your wrong formula. All right, the fact is I can just reduce the speed of this to 2.5, all right, and now you're going to think these two things, right, that now they're factually going to have the same energy. You know, now they're actually going to have the same energy. So, and you're going to be 100% off in terms of what you pick, because you really don't understand any of this in any kind of rational way. You don't understand how you have to be careful how you collect the energy. You just have this delusion that how far something goes means what and how much energy it has. So again, if I put if I say, oh, well, I'm gonna have an elephant sit on your mother's head, or I'm going to shoot her with a .45 caliber gun, or some kind of circumstance like that, you can't get the right answer because you think because the bullet's going faster it has more energy. You're just stupid. Yeah, I mean, it's just, you're belligerently stupid. It's just clear and obvious. All right. Yeah. So momentum can't be energy. It's so he says it's just a result of Newton's law that for every force there is an equal force in opposite direction. Well, there obviously isn't when it's traveling freely through space or something. So, and if there is an equal force, then you'd have to argue that the equal force has been mitigated by something, because it's obviously not working. The opposite direction isn't able to stop the thing from moving. So it's a little bit silly to use this kind of rhetoric. What Newton said is for every action, there's an opposite reaction. All right, in the sense that there's no free movement lunch. If something moves, it does actually have to be pushed. But anyway, if different objects bang into each other, so here we go, he's just going to make the same argument again, okay, claiming there's losses when there isn't. If different objects bang into each other, the sum of their forces remains the same. So again, that's absolute nonsense. Obviously, because the sum of their forces can be in the form of sound and all kinds of different things, all kinds of losses. So you're just contradicting yourself. Now, 1 minute there's losses all over the place. The next minute you're saying the sum of their forces remains the same. And what's the sum of their forces? Again, if I compress a spring, what's the sum of the condition of the spring here and the condition of the spring compressed? Those two aren't the same thing. The spring is obviously storing the energy, and it can release the energy some later time on some other object. So that doesn't even make any sense. Anyway, to change the momentum, here we go, or to preserve it, right? We need to add an external force. Not by your reasoning. So again, if I take the same spring and I compress it to the same distance, and I put the 10-pound thing on the spring and shoot it, and then I put the 5-pound thing on the spring and shoot it, what do you think the end result is going to be? I mean, you do understand that, yes, the lighter thing goes further, but it doesn't mean it had more energy. Obviously, it goes further. It's lighter. How is it more energy? And if I bang that thing into another spring on the other side, it's going to compress the spring the same amount. Right? I mean, whether I put the 5 velocity thing with the half the mass, or I put the 10-pound thing with half the velocity between two springs, they're both going to compress the spring exactly the same amount. Do you disagree? Do you think the 5-pound object is going to compress the spring twice as much or some measurable amount more? I mean, can you actually stand by something and demonstrate it and say it overtly? That, yes, you say that if I have a spring system, there's a spring on this side and a spring on this side, and I put the twice as massive object that's going half the speed, and then I put the other object that's going twice as fast but half the mass, and I put them in this spring, right? I compress this spring's open, and I put them on this spring, and they bounce back and forth on a little air channel. Do you think the two objects are going to compress the spring some different amount? The spring has put the energy in. Okay? This spring is going to collect the energy. Do you really think that this spring is going to compress more and then it's going to compress this spring more? I mean, it can't really do that, right? If you're going to give it twice as much energy, right? The two things shoot off. They're going to get reflected on the other side. All the energy is going to be shot back. 99.9% of the energy is going to be coming back again. Do you really think the original spring is now going to be pushed back further? That would be a pendulum where you drop it and it actually goes higher. That would be preposterous. It never happened in the history of all experimentation. It's just absolute nonsense. It's above unity. It's all of those things. You're the one who's just being so belligerently illogical. Oh, Jesus. All right, I'm no expert on physics. Oh, but you can do this shit. You can make this commentary based on the fact that you're not even saying you have some expertise. I've at least done some research, done some work, watched a few hundred physics lectures, and yet you're questioning my competence, and you're conceding you don't know what the fuck you're talking about. All right. But one thing I've learned is that it's always intuitive. Oh, no, it's not. The ferrocell says light is bent by magnetism. Do you think that intuition is correct? No, it isn't. Walter Lewin has plenty of experiments. No, MIT has plenty of experiments. That's the other thing that was sort of demonstrated, is that I can go back to all the 50s and 60s videos made by MIT, and half, at least, of Professor Lewin's experiments are exact duplicates of what they did in 1950. Even shooting a silly little monkey off a stick. I mean, it really is sort of embarrassing, in my opinion, that Professor Lewin had the pretense that these experiments were his contrivance, because they really weren't. They were just engineered for the purpose of demonstration. And because they want to demonstrate a certain point, they have emphasized and distorted the evidence to illustrate the point. They've engineered the experiment. And I've shown you other examples of these engineered. I've showed you the Veritasium video where he's obviously got a photo detector turned way the fuck up when there's no reason he should have to have it way the fuck turned up. And the reason why he has it way the fuck turned up is because he has to find an excuse to shorten the duration of the experiment, because the fact is the experiment didn't work when he waited a long time for photons to be shot through the experiment. It didn't work. Alright, but you're such a liar and a scum and a shit talker and a fucking goddamn lousy, rotten, stinking, dishonest piece of shit, Jerry. Alright, speaking of, some other asshole posted the stupid fucking comment on my video. Well, this doesn't have the derivative in it, so let me go here and see if I can find the one that has This is the one, yeah, where I put it in caps so you can actually read it better. All right. So he posted as a comment and then disappeared. I mean, I went to the trouble to actually counter his points, and then the comment just vanished. And then he sent it to me in email. So I thought that was kind of funny. So I can't remember his name. It was some stoned moron or something, whatever. So he says, "You are a stunning fucking moron." I say, "Back at you. The magnetic field is isolated inside the solenoid." Well, clearly Professor Lewin's argument was it isn't isolated in the solenoid. So as much as you think that's how reality works, well, the fact is it doesn't really work that way. There's a very small magnetic field that goes outside, but it's there. It's real. Okay, you can't prevent that kind of leakage, and especially at the ends of the coil. So we know if the coil is placed on a flat surface, and the coil is going up this way, and I place it on a flat circuit board, well, we know the end that's leaking a lot is the end that's right on the circuit board. So right there, that argument is defeated by the fact that there's lots of leakage at the two ends. So you're wrong in that sense, and you're wrong as some sort of fact. The magnetic field doesn't stay inside the coil. It just doesn't. There's a lot more of it in the coil, but it leaks out. There's plenty of magnetic field around any transformer. You can't avoid it. Asshole. Okay, so let's understand. I mean, Professor Lewin defined the circumstances of this. I'll draw it a different way this time, just because it's so silly in terms of how simple the experiment is. Okay, so you just have these 2 points, 2 resistors in parallel, okay, and they're 2 different resistances, all right, 100 and let's say 500, and that's all it is, okay, and you're just going to take a meter and measure the voltage over here, and then you're going to take a meter over here and measure the voltage, and you're going to get 2 different voltages. One voltage is going to say it's 0.9, one of them's going to say it's minus 0.1, all right, on your 2 meters. And the difference is once he takes the battery out, he puts an inductor. He puts the coil right here. Okay, so the coil is in the middle of the experiment. The 2 resistors on either side, the 2 bare wires on this side. And he's just measuring the voltage between these 2 points. That's the experiment. Oh, I should. Sorry about that. I'll have to keep track of. All right, so it's pretty simple. Inductor here in the middle. And now there's going to be a voltage created in this wire that's going to be 1 volt. So he's got the inductor. He's put enough, the voltage in the inductor is the right amount, okay, and it's just the charging voltage. That is the voltage it takes to charge up the magnetic field of the inductor. And so it's just the charging voltage. So there's no other event. It's just the charging voltage. No turning it on and off, no changes in the magnetic field except the charging it up field. And he's engineered it so there's 1 volt that's going to be moving through this wire. All right, and these are the results. And clearly the point is that as this field is inducing electricity in this wire, this field is inducing electricity in these probe wires. And that's the simple explanation and argument about what's taking place. There are not 2 voltages here. This voltage is with the current. This voltage is against the current. That's why this is a negative, this is a positive. So this arrogant asshole makes this argument that's completely counter to explicitly what Professor Lewin's arguing. He's inducing a current. There's no current he put in the 2 resistors. The current's being induced by the coil. So it's kind of idiotic for you to tell me there's no magnetic field when Professor Lewin's depending on its existence to create the current in the wire. Oh, okay, so again, let's just understand. The magnetic field is isolated inside the solenoid. No, it isn't. So I said that. If that were true, there could not be 1 volt in the circuit. There obviously couldn't be 1 volt because there's no other place to get the voltage except from the inductor. Moron. All right. and it runs perpendicular to the board. So I say to that, the coil is perpendicular, pointed up to the circuit. So there's no point in talking about the direction of the magnetic field, and the point is you're charging it. The field is going to move out as it intensifies. And that's all you have. So the field is moving because it's charging. It's not moving like I moved it or I did this with it. He's not moving the coil to create an induced current in the wire. He's charging it. Okay, what you drew has no connection to reality. So I drew exactly what the experiment is. No doubt about it. Completely accurate. Absolutely no reason for this idiotic statement that he'll back up with nothing. It's an exact replica of the experiment. Okay. What I drew is the actual circuit that the experiment has been performed using. So you can modify it. Like I said, you can make it triangular. You can change the shape of it. You can do different things. But it's just really two parallel resistors. Okay, they're in parallel. And all you're doing is putting something in between the two parallel resistors. That's all this is. Okay, it's so simple a circuit. You can't get any simpler, frankly. And call it a circuit. So it's just really irritating when, this is just such crap. I mean, Electric Boom did it so many. He had different coils. He tried all kinds of different things. So this has nothing to do with any inaccuracy in the drawing, you crazy bastard. I've seen it performed more than once. How dare you make a statement like that? Did you back up with nothing? All right, anyway. Because that's not how the magnetic field lines curl. So this isn't about curl. Because I'm not moving something. It's about the fact that when you charge the coil, there's automatically a changing magnetic field. It's the same thing as me pushing a magnet into a wire. Same exact thing. I'm moving the magnet into the wire. That's the same thing as charging an electromagnet. Charging an electromagnet is exactly the same thing as moving a magnet into a wire. All right. Wrong and irrelevant. It is a charging magnetic field turning on. It's not a moving field. Okay. I mean, I can't, people are just so obnoxious. Moreover, you can't have any voltage unless you defined a reference point. Well, clearly the reference point is the two sides of the parallel resistors. The one side and the other side of the parallel resistors. The reference points are clearly defined. All right, anyway. The circuit has two resistors in parallel. The reference point is the voltage difference across the resistors. I mean, you can't make it any simpler, right? I mean, there's two resistors, and there's wires on either end. They're tied together, and all you're doing is measuring the voltage across the two resistors in parallel. What an idiot. All right, anyway. Let's see. Voltage can be defined as a potential difference between two different locations. The points to which the voltage meters are connected is clearly illustrated. I mean, I can't make it more obvious, right? I mean, these are the 2 points. These are the two resistors. They're in parallel. You're measuring the voltage from here to here across the resistors. I mean, you can't make it any simpler. I mean, there's not really a simpler electrical circuit I could describe, and here this idiot is telling me, oh, yeah, really, it can't be. I can't make it any simpler. I mean, this is just so insane that these arrogant assholes do this crap. All right, anyway. And in the case of a changing magnetic field, it can only be defined along a path between two locations. So again, obviously there's two locations. They're in Lewin's drawings. They're in all my drawings. The two locations are obvious. They're little points. You draw them with little dots. I mean, I illustrated them very clearly. This dot right here. You see this dot and you see this dot here? I clearly illustrated the dots where the meters are connected. I mean, how can you be missing this? Oh, God, what an asshole. Anyway. So I said, the coiled inductor is placed between the two parallel resistors. What else? What can you say? Anyway, you don't have the slightest clue what you're talking about. And I just say, well, you are ugly, smelly jerk. I mean, it's just so amazing that people can be this obnoxious, this arrogant, and they're so fucking wrong. All right, you don't have the slightest clue talking about how far a ball goes up versus initial velocity. So here we go again. I've already pointed out that, yeah, I was wrong about gravity, but let's use the reality and point out, why does it happen? Why does an object go 4 times further, okay, based on how fast it's going? Why? Why does that happen? Why does twice the velocity add up to 4 times the height? Why? Oh, that's right, because gravity is a continuous force pushing down, and the faster you go, the less of it you're going to hit. Duh. So that argument is indestructible. It's a fact. That's how gravity works. You can't refute it. You're an idiot and a moron. Anyway. But I do know that if you lift an object slowly in gravity, it will require more energy to lift it to the given height. So all of us can understand the simple analogy. If you're lifting a big heavy weight, the slower you lift it, the more calories you're burning. All right. And you don't have the slightest clue talking about energy to start with. So here we go. Prove it with something called evidence. So prove I'm clueless. So I'm offering, thousands of dollars for somebody to prove I'm clueless. They can just demonstrate it. Just play a 17-minute video demonstrating that I'm clueless. But you can't do any of that. You're not doing any of that. You're not linking to anything. Okay, I can't imagine what worms are rotting your whatever brain dead skull. And I just point out, I believe you have a very tiny penis. But enjoy living the rest of your pathetic life as a lobotomized kook. Time will tell. I mean, that's I'm probably not going to get much reward out of my existence. So, like a lot of the heroes of the past, I'm just going to get abused by these assholes called human beings. Okay, they are very uneducable. They're retarded. They just shit and piss and puke on you. It's a nursery school nightmare, and I have this ugly, horrible job of having to, manage the morons. But the truth will be is that you're going to be the sack of shit, okay? You're going to be on the ash heap of dumbass, not me. Get what you fucking deserve. And yes, that's what I would truly love, okay, is that we all get exactly what we have earned. All right, so you say because I'm rejecting your silly religion, I deserve what? What should be my horrible punishment for saying religion is moronic, okay, and human beings can do better? All right, I can only hope that you will be your fate as well. So, yeah. But man, you people are just so fucking obnoxious. And again, they're all unaccountable. They don't make any videos. They don't do a motherfucking thing. They don't really put their reputation on the line. They're all just hiding behind their little fucking rocks, throwing their little fucking poo. And they're just such cowards. Pathetic cowards. Alright. At least this Richie guy has the balls to sit up and make his crazy statements. Doesn't really improve it though, really, frankly, because you're just making noise. You're just wasting people's time. They're going to have to explain to you that you didn't do this thing you think you did. Ugh, but whatever. Such a nightmare planet. You really are less than apes. Fish. You're still just dumbass fish. Swimming in your own poo. Alright, anyway, so that's probably enough, right? Yeah. I don't think there were any other comments that were even coherent, so what's the point? Yeah, this whole Newton's first law states, it's just, waste of time. You have to understand that the laws you can't make a law about different circumstances. The conveyor belt being on, and it's dropping lead bricks on your head, and the belt being off are two fundamentally different circumstances. And it's just kind of silly to say, oh, I have one law that fits every circumstance. Anyway, till the next time and such, and so forth and whatnot. Yeah, it's just really nothing else worth the trouble. Ugh. I hate this planet. I do hate it. Hate it here. Yeah. So, till the next time and such, this has been a DraftScience video presentation. Such.